Welcome to the deep dive. Today we're tackling something pretty interesting about a sequence you probably know, Fibonacci.
Mm-hmm.
A listener sent over a paper, and it really makes you pause and, well, reconsider what the sequence fundamentally is. Maybe more than just, a math thing.
Exactly. The big question we're digging into is, does Fibonacci actually have a starting point? Or is its very nature infinite, stretching back forever?
Okay, right. Let's unpack this a bit. The definition we all learn is, simple. Each number is the sum of the two before it. 0, 1, 1, 2, 3. Keeps going.
Yeah, the standard sequence.
But this paper asks, okay, wait a minute. Where did that initial 0 and 1, materialize from?
Yeah.
If every single number needs the 2 before it.
Then that starting point feels a bit plucked out of nowhere, doesn't it?
Exactly. It
Yeah,
feels
sure.
slightly arbitrary. That's the puzzle here.
And the author's argument is pretty direct. If you strictly follow that rule, every term must be the sum of the two preceding ones, then that logic doesn't just stop. It has to extend backward.
Infinitely backwards.
Infinitely backwards. It's not just, oh, let's see what happens if we go left. It's presented as a logical necessity. An infinite past sequence is required.
So that sequence looks different. It's like, 3, 2, 1 is 1, 1, 0, 1, 1, 2, 3. Continuing both ways.
That's the one.
And the point isn't just that you can extend it, but that you must for the definition to be truly consistent. The author calls it an ontological proposition.
Which basically means for the sequence to be what it claims to be, it needs this infinite nature. It's part of its existence. If
Yeah.
that chain breaks somewhere in the past.
The whole definition kind of falls apart. Or
Yeah.
it becomes unstable, at least from this viewpoint.
Yeah, that's the idea. And what's really neat is what the author terms asymmetrical symmetry.
Okay, what's that?
If you look at the whole infinite sequence, the numbers on the negative side, you see values like 1, 3, 8 appearing again.
Oh, like on the positive side?
Kind of, but mirrored. They appear with alternating signs, and the pattern is sort of flipped. So same magnitudes, but presented differently.
Interesting. Okay, now connect this to the golden ratio, because that's where Fibonacci usually gets really fascinating, right? Phi, about 1.618.
Right, the classic golden ratio. You get that by looking at the ratio of successive terms as the sequence goes off to the right towards positive infinity, fm plus 1, fn.
Standard stuff. But what about the other side, the negative index part?
Well, this is the author's key move. If you
Yeah.
look specifically at the positive valued terms on that negative side, so skipping the negatives, you get 1, 2, 5, 13, 34.
Okay. And the ratio between those terms.
That ratio, as you go further left, approaches a different number. It approaches roughly 2.618.
Wait, 2.618, and isn't that phi squared? Like 1.618 times itself.
Precisely. It's its supplement chaff. And this leads to the author's really bold claim.
Which is?
Maybe the standard golden ratio phi isn't the most fundamental constant derived from this sequence. Maybe phi squared, this 2.618, is actually more foundational.
Wow, okay. How so? Especially thinking geometrically, like spirals.
Exactly like spirals. We know the standard spiral based on squares derived from the 0, 1, 1, 2, 3 sequence.
Yeah, the classic image.
But this paper proposes a different spiral, one based on SPA generated from those positive terms found on the negative index side, the 1, 2, 5, 13 sequence.
And this isn't just like an alternative spiral.
No, the argument is stronger. It's positioned as the underlying dynamic. This left-generating spiral is suggested to be what actually gives the familiar spiral its legitimacy.
So the standard spiral we see everywhere is actually dependent on this other one, the one generated from the infinite past.
That's the core assertion. The existence and sort of the mathematical grounding of the standard golden ratio spiral relies entirely on the sequence generating infinitely backwards if you cut off that infinite past.
Then the regular spiral loses its foundation, according to this view.
It loses its legitimacy, yeah. It becomes just an interesting pattern maybe, but not rooted in the fundamental definition of the sequence itself.
The author has a striking way of putting it, right?
Yeah.
Something like,
First, there is Pfaff. That's the quote. And this spiral, born from the negative side, is described almost poetically as a universal consciousness breathing in the infinity of the past.
that's quite a concept. Really shifts the perspective.
It absolutely does. So wrapping it up, this paper really throws a wrench into the simple view of Fibonacci. It argues its definition demands an infinite past.
And by doing that, it potentially promotes Pfaff, not Fav, to a more fundamental status with his own generating spiral.
Exactly. It connects the definition, the infinite nature, and this other ratio of Pfaff together.
So here's something to think about for you listening. How often do we take definitions at face value? You know, something seems simple, like the Fibonacci sequence starting at 0 and 1. But could there be hidden depths? Could other seemingly straightforward concepts actually rely on an unseen, maybe infinite foundation just to be what they are? It's definitely something to mull over.
A fascinating question indeed.
Thanks for taking this deep dive with us.